Hello and welcome to this lecture. Postgres joins are used to retrieve data from multiple tables. A Postgres join is usually performed whenever two or more tables are joined in a SQL statement. Also, tables that are participating in the join must have related columns between them. There are several types of joins you can perform in Postgres. You can perform inner join, left join, full out join, a cross join, and a natural join. We will be covering each of these types of joins in this section. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres natural join to query data from two or more tables. A natural join is a join that creates an implicit join based on the same or matching column names in a joined table or joined table. Natural join can also be an inner join, left join, or a right join. A right join basically is the opposite of a left join, in that with a right join, all the records from the right join are returned, followed by any matching from the left join. Left join meaning any records matching from the left table. So it will return everything from the right table and anything that matches on the left table. That's what is known as a right join. If you do not specify the type of natural join you are using, by default Postgres will make it an inner join. So the default is an inner join. So when you are using a natural join, if you don't specify if it's an inner join, a left join, or right join, Postgres will automatically assume it's an inner join. Let's have a look at the syntax to see how you would implement a natural join. So this is the syntax. Basically, you select all from the column, if you're using all columns, and then from the first table, and then you specify a natural join. If you want the natural join to be, say, a left join, you have to indicate that inside square brackets. If you don't indicate that, the natural join will implement an inner join. If you also use asterisks rather than the actual column names, if you use that in the select list, the result will contain all the common columns, which are the columns in both tables that have the same name. Every column in the first and the second tables that is not a common column. So using the asterisk will produces what it will generate first. It will give you all the common columns which are common in both tables that have the same name, and also every column in the first and second tables that is not a common column. That is where the names don't match. All right, let's go over to our admin tool and implement this. So I'm going to use a couple of tables here from our sample database. Sample database is DVD rental, and these are the tables. Got 15 tables. So I am going to use the customer table and the payment table. So let me expand that so we can see the tables. This is the customer table. It's got 10 columns And I'm also going to use the payment table. Payment table has got 6 columns. So when I implement the natural join, what should happen? All the common columns which are identical in both tables will be displayed. Also, all the columns in the first and second table that also do not have matching columns will also be displayed. So let me do that now. Let's right click on the table and go query tool. Okay, so what I'm going to do, I'm going to select all the columns. I'll do select star, means get all the columns from the customer table first, table called customer, and I'm going to do a natural join. Because I've not specified what type of natural join, it will make it an inner join. So if I wanted it to be a left join or a right join, I will indicate that. But because I've not, Postgres will assume it to be an inner join. So I'll do a natural join on the second table, which is the payment table. That is basically it. The query is completed. So what should happen? It will return columns from both tables. Let me run that so you can see. So it has returned over 14,000 records from both tables. So this query here is basically the same as an inner join. All right. So if I was to modify this, it will to an inner join, it will give me the same result. Say for example, I do select star from customers. Okay, and I do an inner join, on the payment table using the customer ID, because customer ID is a column that is present in both tables. So if I execute this query, it should give me the same output. All right, so this is the first query here for the natural join, which, because I've not specified what type of natural join, it makes it an inner join by default. This query also can also be written as an inner join. If I was to write this as an inner join, it will give me the same result, the same output of over 14,000. So let me run this and you can see that. If I execute, look at here, it should show over 14,000 records. If it doesn't, then you see that it's shown over 14,000. So it's giving me exactly the same output. The convenience of using the natural join is that it does not require you to specify the join clause, because it uses an implicit join clause based on the common columns. I would be cautious using natural joins, because sometimes it can give you unexpected results. All right, so let me show you another example of how you can get unexpected results. So I'm going to pick 2 other columns here. I'm going to use 2 tables. So I'm going to use the city table and the city table here and the country table. I'm going to perform a natural join and you will see what I mean by unexpected result. So I'll start with a select statement. I'll do a select and it will be star from city which is the city table here, and I'm going to do a natural join with the country table, which is this table here. So if I run this, you'll be surprised at the result. You get something probably you didn't expect. So let me run that. As you can see, total query runtime, 0 records retrieved. But it's displayed the names of the columns, but no rows. The reason the query result is empty is that both tables have a common column name called last update, which cannot be used for the join. However, the natural join clause, this one, just uses the last update column. Okay, so you can see what I mean by you can sometimes get unexpected results. In this lecture, I have explained how to use the natural join to retrieve data from multiple tables. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres cross join to produce the Cartesian product of rows in the joined table. Basically, a cross join allows you to produce the Cartesian product of rows in 2 or more tables. With a Cartesian join or cross join, the cross join is also referred to as a Cartesian join. With a cross join, the participating tables, you can join tables without having to specify matching columns conditions inside the join clause. So when you're using a cross join, it's easy to just join 2 tables that are not necessarily related by matching columns. So using a cross join, you can combine 2 tables together completely, whereby you return all the columns from one table added to the columns of the other table to produce a new product, which is known as a Cartesian product. So the tables participating in a cross join does not have to have matching columns in the join clause, whereas the other types of cross join, normally you can specify a condition in the join clause for the matching columns. You don't have to do that with the cross or Cartesian join. Let's take a look at a simple syntax of a cross or Cartesian join. So basically, this is what the syntax looks like. Fairly basic. You select, for example, all the columns from table 1 and you cross join it to all the columns in table 2. That's basically it. So let's see how this works. I have logged into my PG admin tool and I'm going to illustrate this Cartesian or cross join with a couple of tables from the DVD rental database, this database here. So let me just scroll down, and the 2 tables I'm going to use are the actor table and the city table. If you look at the columns of the actor table, there are 4 columns. Actor ID, first name, last update. If I check the table, the columns in the city table, there are also 4 columns. City ID, city, country ID, last update. There are no matching columns from both tables, but we can still perform a Cartesian join. So we can join these 2 tables together to create what is known as Cartesian product of rows. So let's go ahead and do that. I'm just going to right click on the first table and go query tool. You can also access the query tool from the tool window here. You can also access it from here. So just that it's quicker to just, if you're already in this area, you can just right click rather than jump to the tools option. So I'll go query tool and I'll wait for the tool to load up. All right, so it's going to be a fairly straightforward query to write. So I begin with this select keyword. I'm going to use all the columns from the table, the first table and the second table, because they're not that many. So I'll do select star. Star means it will retrieve all the columns from the table, and then I specify the from field and indicate the name of the table. So the first table is going to be the actor table. Actor, and then this is where I add the join. So I'll do a cross join on the name of the second table, which is the city table. And that's basically it. Because I've indicated asterisk here, that means it will produce an output that contains all the columns of the first table, which is the actor table, and the second table, which is the city table. If you notice also, there is no on keyword, because with a cross join, you don't have to specify matching columns. So now if I run this query, it should produce an output that consists of all the columns from the actor table and all the columns from the city table. So let's give that a go. I'm going to click on this and wait for the query to execute. The query might take a little longer than the other types of join because it's trying to combine data from both tables into one. So there you go, it has finished. So this is the output from the cross join. So if we look at the output here, you can see that the first four columns, actor ID, first name, last name, or last update, come from the actor table. And then the other columns, city ID, city, column ID, and last update, city ID, city, country ID, and last update all come from the city table. So this is how you perform a cross join, and it produces a new product called a Cartesian product, because you're creating a new product from the combination of two or more tables. So that's it for this lecture. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to select data from multiple tables by using the Postgres inner join clause. With the inner join, it will return records that have matching columns from the participating tables. So any record returned from using the inner join will have matching values from the columns in both tables. What that means is that the participating tables must have columns that are matching. For example, you can have on one table, they've got a column called Joe Blogs. On the other table, they must also have a column called Joe Blogs. Let's have a look at a simple syntax of how to implement an inner join. So this is the syntax, just a basic syntax here. So you select the column names from the participating tables. In the from field, you specify the first table, and then you perform the inner join on the second table. And this is how you use the on keyword to indicate this is what actually implements the join. It's like a glue. That's what glues it on. So you do an inner join on table B on table A dot column. That is the column from table A where you're performing the join on. Will be, you set that to equals to the column on table B. It will make more sense if I actually show you how an example of how this works. So this is just a simple illustration here. We've got a table A here and a table B. So you will have, it will return records that match columns from both tables. So they must have participating columns that match. I am going to perform an inner join on two tables that belong to the DVD rental sample database, this database here. So let me expand the tables here and I'll tell you the two tables I'm going to use for the inner join. So I'm going to use the customer table, which is this table here, and the payment table. So one of the criteria in a table join is that the tables that are participating in the join must have columns that match. So let me look at the customer table first. You can see the customer table. These are the tables in the customer table. And it has a customer ID, store ID, first name, last name, and so on. So I want you to take note of this. It has a customer ID. Now let's look at the payment table. You can see here the payment table has 6 columns. It also has a customer ID. All right, so this customer ID here matches the customer ID for the customer table. So we have a matching column. So these two tables can participate in the join. This is an illustration of the relationship between the two tables that I am going to use to illustrate the inner join. This is a customer table. It has a customer ID, which is the primary key on this table. And you have a customer ID on this table called payment. Although it's not the primary key, but there is a relationship. You can see that of all the columns here and of all the columns here, the columns that match is the customer underscore ID and the customer underscore ID here. So those are the two columns we are going to use for the inner join operation. So looking at this ERD diagram here, this basically indicates one-to-many relationships. So basically what this means is that each customer may have 0 or many payments. See, that's the 0 there. May have 0 or many payments. Each payment belongs to one and only one customer. That's what this is. All right. So the link between these two tables is established via the customer ID field, which is this field here and this field there. To save time, so that you don't have to watch me type all the statement for the query, I've already pre-written the query. I'm just going to explain it to you. So I'm just going to right click on the first table here, the customer, and click on the query tool. And once the query tool launches, I will paste the code I've written into that, and then I'll run through it with. So this is the code I've written here, and in this statement here, I have used the inner join clause, this inner join clause here, to join the customer table to the payment table. So let me start with the first statement here. So the select statement basically is what will read or get the data out of the table. And I've got the customer dot. The dot here indicates that this field here, customer ID, this column is coming from the customer table. So you separate the column from the table name with a period or a dot. That's what this means. Customer underscore ID is coming from the customer table. The first name also is coming from the customer table. Last name also customer table. Email here, the amount from the customer table as well. Sorry about I may have confused you a little bit. Let me just run through this again. I'll start again. You start with a select statement. So you need the select keyword to retrieve data from a table. And here, because we have two customer ID fields we're going to use, customer ID that belongs to the customer table and the customer ID that belongs to the payment table. All the columns listed here are the columns that will be displayed when the query has been executed, and when it outputs, these are all the columns it's going to output. The reason I've got the customer underscore ID here, so that it differentiates that this customer ID here that's going to be displayed in the output belongs to the customer table. That's the main purpose of this, to differentiate this customer ID from the customer ID in the payment table. The first underscore name is coming from this customer table. The last underscore name is coming from the customer table, and also is the email. The amount comes from the payment table, and the payment date also comes from the payment table. So I've got two columns that are coming from the payment table, and the others are coming from the customer table. So now in the from field, we are specifying the customer table. Okay, so all the customer table is where we're specifying the from field, and the inner join, we're doing the inner join on. Notice after the inner join clause, we specify the name of the other table participating in the join, which is the payment table, and we use the on keyword to indicate where the join is going to take place, kind of like where the glue is going to be placed. So the join is on the customer underscore ID table, or the customer underscore ID column that belongs to the payment table. We're going to set that to equals to the customer ID table that belongs to the customer table. So it's going to combine the records from these two tables when the query outputs. So let's give that a go. Run the query. If everything goes okay, we should see a good output. All right, so we've got over 14,000 rows retrieved. So we now have the customer ID, customer underscore ID field is a combination from both the customer table and the payment table. All right, so that when it says this customer ID from this payment equals to that, this is where the join takes place. So you can see now we've now got data from multiple table courtesy of a join, an inner join using columns that match in both tables. This illustration is just on two tables. You can perform a join on many tables as possible, as long as you have columns from all the participating tables that match. Thank you so much for watching. Take care and bye for now. If there are any aspects of this lecture you do not understand, please feel free to let me know. Many thanks and bye. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres left join clause to select data from multiple tables. When you use the left join clause, it will return all the records from the left table in the join, and also any records that have been matched from the right table. If there are no matching records from the right table, nothing is returned from the right table, but it will return all the records from the left table. Let's have a look at the syntax on how you would write a left join. So this is the syntax. Basically, you start with a select keyword and the column names, and you select the first table, which is the table on the left, and then you left join the second table on table 1, dot the column name from table 1, and you set the column name from table 1 to match the column name in table 2. So this, where it's got the equals to here, is where you have the matching column where the join is actually performed. So let's have a look at an example. So this is just an illustration here. In this illustration here, you can see that all the records from the left table are returned, hence it's all shaded, and any record that is matched from the right table, you can see the right table, only this bit here is shaded, which means it will only match the records that meet the criteria set in the join clause. All right, so if it doesn't match these areas, the white areas here, the data has not been matched. The only matched area is this shaded area here. So let's have a look at a quick ER diagram. ER basically means entity relationship diagram. So it kind of like gives you a diagram of the relationship between two tables. These are a couple of tables from our sample database, which is the DVD database. I'm going to use that database to illustrate how we perform a left join. I just wanted to show you the actual diagram to show the relationship between these two tables we are going to use. This table here, called the film table, has a primary key, which is the film underscore ID. If you look at the inventory table, it also has a film ID column. So these two tables here have a relationship, and we can perform a join based on the matching columns from both tables. What this diagram is saying here, this ER diagram, basically it says that each row in the film table, this table here, each row in the film table may have 0, you can see the 0 here, may have 0 or many rows in the inventory table. This here indicates many. So each row in the film table may have 0 or many rows in the inventory table. Also, each row in the inventory table has 1 and only 1 row in the film table. So you can see here, that's why you've got this. This means many. You can see here there's only a single, which indicates that each row in the inventory table has only 1 and only 1 row in the film table. So this kind of like gives you a relationship diagram. It's called an entity relationship diagram. Shows you the relationship between the entities of both tables. So now let's head over to our PG admin tool and implement this join between these two tables. So this is the admin tool here, and this is the DVD rental database, and these are the tables. So the two tables we are going to use in this join is the film table. Let's look at the film table quickly, and you can see it has 13 columns. We've got a film ID column, and if we look on the other table, which is the inventory table, we should have a film ID column as well. So this is a film ID column. So we are performing the join based on these two tables having a matching column. That's where the relationship is. So let me quickly open up our query tool. I'm going to right click on let me go back to the film table. I'm going to right click on the film table and go query tool, and that will launch the query editor. So what I've done to save time, I've pre-written the script. I'm just going to copy that in and explain it. So this is a query to perform the join. So what I've basically done here, you can see that I have used the left join clause to join the film table to the inventory table. All right. So we start with the select statement. If you're reading data from a table, you always use the select keyword. So this start with the select keyword, and then I specify the columns that will be displayed in the output. Because I'm using identical columns from the film table and the inventory table, it is the film_ID column from the film table that will take precedence. That's the table, that's the column that will display after the join has been performed. So hence I've got film_ID dot film. The dot indicates that this column here is coming from the film table. Next, I've got the title here dot film, which indicates that this title column here is coming from the film table. And then we've got the inventory ID, which is coming from the inventory table. And the from is from the film table. The film table is the first table. That will be the table on the left. So it will return every record that matches from the left table and part of the record that matches from the right table. So on the right table, it will return things like the inventory ID, because that should match. So let me execute. This is the join now. After the from field, we've got the left join, which is the keyword. This is what actually you have to indicate to perform the join. So we're performing a left join on the inventory table, and we're using this on keyword. Without that, the join does not happen. That's what glues it together. So we're using the on keyword, and we're specifying the columns that are involved in the join. So we're joining the film_ID column that belongs to the inventory table. We're joining that to match the film_ID column in the film table. So the join has been performed using just these keywords here. So let me execute so you can see. All right, so the join has been performed. As you can see, the columns listed in the select statement and the ones you can see here. Film_ID, this ID here, that's the one there. The title is this title, and the inventory is coming from the inventory table. So that's how you perform a left outer join. We can modify this query slightly because sometimes you find rows that may be empty. For example, in the films table, there are some rows in the film tables that do not have corresponding rows in the inventory table. So the values of the inventory ID will become null. Null means there's no value. So what we can do, we can add a where clause to select only films that are not in the inventory table. So let's modify this slightly to include a where clause. So what I'm going to do, I'm going to take off this semicolon here to indicate that we're adding to the statement, and I'm going to attach a where clause. So I'm going to say where inventory dot film_ID is null. So let me run that again. You can see we've got much reduced rows here. So we've actually filtered the result down by specifying where the film ID is null. So we've changed the conditions slightly with the where clause. So by adding the where clause, it only selects films that are not in the inventory. All right, so this is what we've done here. This technique can be useful when you want to select data in one table that does not have a match in another table. Thank you so much. In this lecture, I've shown you how to use the left join in Postgres to select rows from one table that may or may not have corresponding rows in another table. Many thanks for watching. Please let me know if you have any questions. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres full outer join to query data from two or more tables. When using the full outer join, it will return data from both the left and the right tables. However, if the rows in the joined tables do not match, the full outer join sets a null value for every column of the table that lacks a matching row. So when the tables are joined, if there are rows that do not match, the full outer join will place a null value in that row. When using the full outer join, for the rows that do match, a single row is included in the result set that contains columns populated from both joined tables. One thing to note is that when using the full outer join, it can potentially return very large result sets, so bear that in mind. Let's have a look at the syntax of how you would implement an outer join. So basically, once you typed in the select statement and you specify the column name, the table, you then add the full outer join clause and you include the second table where you are performing the join on. And obviously you need the on keyword, and then you select the column name from the first table that will match the column name from the second table. This is just an illustration of what the full outer join looks like. So it populates both tables with data. Suppose we want to perform a full outer join of two tables. I'll call it table A and table B. The following this syntax here indicates the full outer join. So we're selecting all the columns from table A and we're performing a full outer join on B, and the matching columns are the ID columns in A and the ID columns in B. The outer keyword here is optional. You don't always have to use it. It is an optional word to use. So what actually happens is the full outer join will combine the results of both the left join and the right join. If left and right join, meaning left table and right table, if the rows in the join tables do not match, the full outer join will set null values. So it will add null values for every column of the tables that lacks a matching row. For the rows that match, a single row is included in the result set that contains columns populated from both joined table. So you can see in the diagram here, rows in A that do not have matching rows in B in this shaded area here. Rows in B that do not have matching rows in A are represented in this shaded area there, while the darker shaded area contains rows that match to both A and B. I'm going to illustrate how the full outer join is implemented using our sample database, which is the DVD rental database. And I'm going to use a couple of tables from this database. I'm going to use tables we probably used before. I'm going to use the film table, this table here, and the inventory table. So let me show you the relationship between these two tables. Both tables are related because they have a matching film underscore ID column. You got the film underscore ID here, which is a primary key, and a film underscore ID here. So they are both related courtesy of both of matching columns. To save time, I have already written the query. I'm just going to paste it in and then run it through with you. I've already shown you the relationship between the film table and the inventory table. They are both related courtesy of the film ID. We've got a film ID column there, and we've got a film ID column here. So we are performing the join based on those matching columns. So I've started off with the select keyword, followed by the film underscore ID column that belongs to the film table. When you have a dot before the column names, it means it identifies what table the column is coming from. The title is also coming from the film table. This is a film table, and we can see the title there. However, the inventory ID is coming from the inventory table here. That's the inventory table, and that's the inventory ID column. And the left table, the main table for the join, is the film table. So that's I would say that's the primary table. Then we implement the clause that will initiate the join. So we type in the full outer join, and we have to specify the second table that is participating in the join, which is the inventory table. And you need the on keyword because that's what glues it together. And we are performing the full outer join on the inventory table on the film underscore ID column that belongs to the film table and the film underscore ID column that belongs to the inventory table. So we're joining data from these two columns. And I've also included an order by to order the data that is returned by the film ID in ascending order, that is from A to Z or from 1 to 100. So let me execute this query so you can see the output. So this is the result of our 4,000 records retrieved. So if you scroll through this record where there are no matching columns or no matching records, it will insert null values. So let me scroll through and you should see a null value soon. Oh, I just spotted one. See, it's inserted a null value where it does not have a matching row to the other column. So it does that by default. It will insert null values. Because there are rows in the film table that do not have corresponding rows in the inventory table. And the full outer join, to compensate for that, inserts a null value in the inventory table to match that missing row. However, if you want to filter this data and if you want it to display, or if you want to show all the records that have the null values, you can do that by adding a where clause. So if I come here, I'll get rid of this semicolon and just tab down and insert a where clause. I'll say where inventory dot film underscore ID. Inventory refers to the table. Film underscore ID refers to the column, the table that is refers to the column in that table. All right, so we'll add the operator is null which means it will return all the records that have null value. So this is quite useful because you may want to just check to see how many records do actually have the null values. So let me run that and you would have much reduced output. So I click run and you can see it's a look of 42. It has now displayed all the records in the inventory table here that has null value. So it's quite a useful thing to add to your query if you want to check what values are null in your returned data. So that is it for this lecture on the full outer join. Many thanks for watching. Bye for now.